Welcome back, and hopefully now you've had a go at the Kp calculations on pages 5 to 7. So in this video we're just going to be going through those calculations, checking that you understand how to lay out the calculations and that you understand how to calculate units. So you're going to need your notes and a calculator just to check some of your calculations. Okay, so this is a nice straightforward question. This will be one of the easiest ones you get because they've already given us the equilibrium number of moles and we're just asked to calculate our Kp expression. So we're going to write down the expression for our Kp. So Kp, using this equation, remember, is going to be the partial pressure of the PCl3 times the partial pressure of the chlorine divided by the partial pressure of the PCl5. So the units for this, I've got atmospheres because my total pressure is measured in atmospheres, times atmospheres divided by atmospheres, so the units just come out as ATM. We'll put that in at the end. So I need to work out the mole fraction and then the partial pressure. So again, I'm going to lay it out very similarly to the way I would lay out an ice table. So I have PCl5, PCl3 and chlorine, and I have my moles. And this is moles at equilibrium. So this equilibrium of moles. So PCl5, I've got 0.33 of a mole. PCl3, 0.67. And I've got the same number of moles of chlorine, which is kind of to be expected because it's a 1-to-1 molar ratio here. So now I need to work out my total. So my total number of moles, I'm just going to add all of those together and I get 1.67. I'm now going to work out my mole fraction. So that's my number of moles, 0.33 divided by 1.67, and the same here, divided by 1.67, and the last one. To find the partial pressure, I'm going to times these numbers by my total pressure, which in this case is 10, and I'm going to put all those numbers into my calculator when I've got them all written down. It's a good idea to actually work out these different stages because if you do make a mistake you can get error carried forward marks. So I'm going to work out my partial pressure here for my PCl5, which is 1.98 and 4.01 and 4.01. Now I need to put those numbers back into my Kp expression. So I have Kp equals my 4.01 times another 4.01 divided by 1.98. So that gives me a final answer of 8.13 ATM. And that's my final answer. Moving on to the second example, this is a little bit more complex because they've given us grams and we need to turn that grams into moles. But we should know this equation from lower sixth. Moles is mass divided by mR. So we're going to again write out my Kp expression. So Kp equals the partial pressure of the ammonia, NH3 squared, divided by partial pressure of the nitrogen times the partial pressure of the hydrogen cubed. And again, we're going to work out the units for that. So I've got ATM on the top, and I've got ATM squared divided by ATM times ATM cubed, and that works out as ATM to the minus 2. So ATM to the minus 2. Again, I'm going to lay it out in a very similar way to the way I would lay out an ice table. So I have my nitrogen, I have my hydrogen, and I have my ammonia, and I want to work out the moles. Well, again, as we said, it's mass divided by mR, so I've got 12.8 grams of hydrogen and 59.6 grams of nitrogen. So I've got 59 9.6 divided by the RMM of nitrogen. Notice it's N2, it's a diatomic gas, so the RMM is 28, and I'm going to do the same for hydrogen and ammonia. So doing that, I get this number of moles of my nitrogen, hydrogen and ammonia. I need my total number of moles, and that will be 10.01 number of moles. So now I have that, I can again work out my mole fraction by going my number of moles, in this case is 2.13 divided by 10.01, and do that again across. So there I've just divided through by 10.01 and worked out my mole fraction. Now you're working off the new notes, so you'll have seen the new notes that it says that we're working at a total pressure of 10 atmospheres. So the partial pressure is simply going to be these numbers times by 10. So now I have my numbers, I just need to put them into my Kp expression and make sure I put in the right powers. So I've got 1.48 squared over 2.13 times 6.40 cubed, and I'm using rounded numbers here. I suggest in the exam you don't round your numbers at this stage, but you should get 3.92 times 10 to the minus 3 ATM, don't forget the units, to the minus 2. So we're moving on to example number 3 on page 6, and this is getting a little bit more complex. We would now need to construct an ice table. So we have my initial number of moles, so I've told I've got 2 moles of sulfur dioxide and I'm mixing them with 1 mole of oxygen. Again, initially, because the sulfur trioxide is a product, you can assume, unless you are told otherwise, that we have 0 amount of it initially. Now we're told in the question that 1/3 of the sulfur dioxide had been converted. So our change is 1/3 of the 2. In other words, and that is a minus that value because we are reducing the amount of sulfur dioxide. So because the ratios here is 2 to 1, if this is minus, this will also be minus, but it'll just be minus 1/3 because it'll be half of this value. And again, because it's a 1 to 1 ratio here, this would be plus 2/3. In other words, the same change that I have here. So at equilibrium, I have, keeping it as thirds at the moment, I have 4/3 of a mole of sulfur dioxide. I have 2/3 left of my oxygen, and I've made 2/3 of my sulfur trioxide. If I add those all together, I get 8/3 total. Now I'm just going to work out my mole fraction. So that's going to be 4/3 divided by 8/3, and this is 2/3 divided by 8/3, and again 2/3 divided by 8/3. So I've worked out there my molar fractions. I'm now going to work out my partial pressure by timesing through by the total pressure. So that's 0.5 times 9, 0.25 times 9, and again 0.25 times 9. So working all that out, my Kp expression, plugging everything in, not forgetting the squared terms, and I get an answer of 0.111 to 3 sig figs, and this is units of ATM to the minus 1. So that's my final answer. So we're looking at the last example on page 7, and this is a very typical exam style question where we've been asked to calculate the Kp using an ice table. So we're going to construct that, initial, change, and at equilibrium. So initially I have 1 mole of hydrogen and 1 mole of iodine. And because again it's a product, initially I can assume, therefore, that I don't have any hydrogen iodide. I'm told that the amount of hydrogen iodide at equilibrium is 1.56. So that goes, if you like, in that box. In other words, the change has been plus 1.56. Again, using my molar ratio, I now need to work out the change of iodine and hydrogen. So because this is a 2-to-1 ratio, I've lost half the amount of hydrogen iodide that I've made. So this will be minus 0.78, and it's the same ratio here, so it's minus 0.78. So at equilibrium, I have 0.22 of mole of hydrogen and 0.22 moles of iodine. I have a total number of moles of 2.0. Adding all of those numbers together. I'm going to use these to work out the mole fraction. So that's 0.22 divided by 2, 0.22 divided by 2, and 1.56 divided by 2. So to do that, next step is I'm going to work out the partial pressures, and the partial pressures is my mole fraction, 0.22 divided by 2, times by the total pressure. And we're told that the total pressure is 1.01 times 10 to the 5 Newton meters to the minus 2, and that works out as 1.01 atmospheres. So I'm going to just times by 1.01 through there. As in this case, the units will cancel, and just like in Kc expressions, if the units will cancel, in this case it's the total pressure which will cancel, because we're squaring by the total pressure on the top and we're dividing by it squared on the bottom, so it will cancel out. So I can just use 1.01, or I can just ignore this completely and just put my mole fractions in. I will get the same number. If I do just want to put the mole fractions in, then the best thing to do is make a little note in the side that because the units cancel, the total pressure will also cancel, and therefore it's not needed. So it doesn't matter if you put in the numbers when you times through by the total pressure, or you just put in the molar fraction numbers, you'll come out with the same answer, 50.3, with no units. Do remember, just like with Kc, if the units will cancel, so will the total pressures, because you're squaring this value on the top and then you're dividing by it squared on the bottom, so it will cancel out. So 50.3 is our answer, and that's probably one of the hardest types of Kp calculations you're going to come across. So that finishes this video, just looking at the examples of the Kp calculations. You're going to be going through a lot more of these in class, but you need to practice using an ice table to work out Kp calculations. So that's all for now. Until next time, take care, stay safe, bye-bye.